So last time we were talking about these two ways of going and dealing with collections, and I thought I would dive into this like functional one a bit more because it's a bit funky. And people are not used to seeing this sort of syntax. Usually, they don't usually teach you in school. So um, let's create a function that takes a function as a parameter. Um, so we'll do fun print with format. Um, we'll This parameter will be called transformer, and it will take a person, and it will transform it into a string. Oops, there we go. And that's our function. And now we want to print out the transformer. We can call this, because it's a function, of this person. Now this just refers to the instance of the object that is here. So it's just going to use itself and send it to the transformer. So it's a little funky, um, and it takes a bit to get used to. But if we see Tom print with format, it gives us our functional things here, our little curly braces to represent that we're in a function. Now we can do this, and this might make it a little bit more clear that we're passing in this function block into this method. And you can see this it person is still there as a parameter. And now we can return person.name is person.age. And just I'm going to comment out the rest of this. This means the code will not run. It's not active. So now it's going to print out Tom is 24 because we passed in this transformer that takes a person and returns a string, and then we put it into this println function. So this is like the println function is a function that wraps a string that was created from a transformer that we created. Okay, that was a lot. But yeah, that's essentially how this works. And now we can uncomment this, and we say, okay, this filter is doing something similar, where it's taking a person and it's saying, okay, it's returning a Boolean if the age equals 24. So in Java, you have this great option where you can go to the source of where this was defined, and we say, whoa, this definition looks pretty complicated. But if we can break it down, we can say, okay, this T, this is a generic. So this will be whatever this is, because that's the generic we defined for this collection. So this T is just a person. This is an iterable of people. And this iterable we don't really have to worry about. This is it's called a superclass, which means essentially we get all of the methods that are defined for this iterable class on our list free of charge. They're just there. We can use them. This is the name of the function. And then this takes in a predicate, which is a fun math term to make things confusing, which takes in a type T. But this T, remember, is a person. It takes a person and returns a true-false value. And we will use that function to make some determinations. And then this larger filter function returns back a list of people. Now in the Java and Kotlin libraries, these things are kind of complicated, where a lot of functions are chained together to make things work together very nicely. But essentially this filter2 is just saying, okay, I'm going to take in a new collection and I'm going to add whatever I mess with in the old collection to this new collection here. So if we go to the definition of this filter2, we see, okay, now we have this destination, which is C. This T is still person. And then we can see a very simple for loop. So this is just a for loop. And it's saying for element in this, the list of people, you say if the function we pass in, which is person age equals 24, we give it the element in the list, we give it the person to work on. We say, okay, if this predicate comes back true, destination, add the element to it. So essentially what this does is this creates a new list. So this whole step essentially does a for loop and creates a new list. And then this one, if we look at this for each here, we say, okay, this is something similar where it doesn't return anything, and our inner function doesn't return anything, but we're essentially taking all of the elements in this, which is the list, and performing an action that we pass through on them. And the action that we're passing through is this print old function. So some people might be wondering now if you've if you've been if you're a nerd or if you've been paying attention super closely, but mainly if you're a nerd, you say, okay, if this is just doing two of these for loops, why would you ever use this? And you have a good point. If this is how like the main use case of this worked, that would be a great point. But the main draw of this sort of like functional style is you get to break the logic into like two separate things, or however many steps that you want. You can do tons of different stuff here. So if we want to add steps, we would say, okay, instead of doing a filter here, I'm going to remove this parameter super easily. I'm going to do something that's called a map, and this essentially just takes a person and transforms it into something else. So if we did person dot name, we now have a list of strings down here. So we can print line this name. And then if you go into this definition, you see, oops, follow the whatever this map to function, we say, okay, this is another for loop. And you're saying, Don, this is getting incredibly more complicated. You're adding so many loops when you do each of these calls. Yes, hold on. But we're now we've broken down the logic into each of these distinct steps, whereas if we want to do it up here, we have to do if name equals 24, print line person dot name. And you're saying, okay, this doesn't get complicated, but when you add more and more of these sort of steps, it gets confusing to write it this way. It's much more visually clear to lots of like programmers, especially like more senior programmers. They will always use this style, from what I've seen. So yeah. But getting back to why this is so, or why this isn't actually three for loops, which seems crazy, is because of another data type called a sequence. In Java, it's called a stream. But essentially, what this does, it essentially collapses all of these for loops down into one this for loop. So now if we go to this filter definition, it's going to be different. We're going to say, okay, this filter, it's a sequence. It takes in a person, which there's our T. It takes in the same predicate and returns a sequence, but it returns a filtering sequence that takes a sequence as its input. Okay, what's this filtering sequence class? So this is where the is where the collapsing happens. Um, so essentially, it does a bunch of complicated stuff, and each of these steps do this. We're at map, transforming sequence. Um, this one's a little bit simpler, actually. Um, and for each just does the same for loop. So this is the only for loop that's left when you collapse this sequence of steps down into um, when you collapse the list down into a sequence, all of these for loops gets rewritten as something else that is not a for loop that doesn't cost that much time. And then this final one will execute the only for loop, and it will collapse and be the same as this. But essentially, when you're dealing with large collections and tons of data, in my opinion, it's a lot easier to look at it this way with these different steps uh, than to try to follow someone's exact methodology through the loop they create up here. And when we create some actual applications, we'll get to see cases where it's a little more useful to have it like this. Yeah, that's it. I'll probably do some more actual like application coding, so like some intro projects after this. I think we've got all the basic stuff that we need to start. Yeah, that's it. Thanks.